So, in this video, we will be dealing with the determination of the water content of a soil mass. That how to determine the water content of a given soil mass through various methods. We will be dealing with a total of 3 methods, 2 of which are the laboratory methods, and the third one is the field method that is readily used in the construction sites. So let us begin. First method that we have is the oven drying method. There are some key points to keep in mind while doing this experiment. That is, it is the simplest and most accurate method, but it is a very time consuming method. You have to wait for at least 24 hours to get the water content value. Now, for inorganic soils, always maintain the temperature between 105 to 110 degrees Celsius. Why? Because below this temperature, the water won't get evaporated, and above this temperature, the structural water that is contained in the geometry of the soil solids will get evaporated, and eventually the soil solids will get destroyed, and we don't want that. Now, for organic soil, do not increase the temperature beyond 60 degrees Celsius, as oxidation of the organic matter will take place, which will lead to formation of some products, and that these products will add on to the mass of the soil, which will give us faulty value of the water content. Next is, a soil having gypsum should not be heated beyond 80 degrees Celsius for the same reason, to not lose the water of the structural water that is entrapped in the geometry of the soil solids. And lastly, in no case the temperature should be increased beyond 110 degrees Celsius for the same reason as I mentioned above, that it will lead to destruction of the soil solids, as it will lose the structural water beyond this temperature. Let us begin with the experiment now. Take an empty container and weigh it. Let us suppose its weight is W1. Fill the container with the soil sample of which you want to determine the water content. Weigh it again. Let us suppose it's W2. Now, keep this sample in oven for 24 hours to evaporate all the water that is contained in it. Now weigh it again. This is W3, the weight of the dry soil sample plus the container. The water content, as we know, is the weight of water divided by the weight of soil solids or the dry soil. Now, the weight of water can be determined by W2 minus W3. W2 is the weight of the container plus the moist soil. W3 is the weight of container plus the dry soil. Subtracting these values will give us the weight of the water. For the weight of the solids, subtract W1 from W3. W1 is the weight of the empty container, and W3 is the weight of the dry soil plus the empty container. So which gives us water content W2 minus W3 by W3 minus W1, and in percentages multiply it with 100. The next method that is somewhat less time taking is the pycnometer method, that is very often used in the laboratory. It is not as much accurate as the oven drying method, but the procedure is fast enough. Now, there is some prerequisite knowledge that one must have prior to performing this experiment. That is, one should know what is the specific gravity of the soil solids, that is the G value. One should know about it. What is this? In technical terms, it is the ratio of the weight of a given volume of soil solids to the weight of equivalent volume of water at 4 degrees Celsius. Now, what this means is that, suppose you want to find the G value. I have taken 4 grams of the soil solid, and suppose these 4 grams are occupying a volume of say 10 cubic centimeters. So I will have to divide it with the weight of that has the same volume of 10 cubic centimeters. So only when the volumes of both these terms are same, then only we can divide their weights and get the value of the G. So this is what the specific gravity of the soil solids mean. Now it can be written as this is the weight of the solids, and this here it should be Bs. It should be Bs. So the volume into the specific gravity of the water will give us the weight of water having the same volume as this solid, which can also be written like this. Ws by Vs is gamma s, which is unit weight of the soil solids. So unit weight of the soil solid divided by unit weight of the water will give us the G value or the specific gravity of the solids. Let us begin with the procedure. Take an empty pycnometer and weigh it. Usually the pycnometers that we have in laboratory has the volume of 900 ml. Now fill it with the moist soil sample and fill it with about 200 to 400 grams of the soil sample and weigh it. Now note here that W2 is the weight of the pycnometer plus the soil here. Now fill the remaining volume of the pycnometer with the water and weigh it again. That comes out to be W3. W3 here is weight of the pycnometer plus the soil plus the water. And lastly, empty all the contents of the pycnometer and fill it with water. Remove the soil and fill the whole pycnometer with water, weigh it, and this is weight of the pycnometer plus weight of the water. Now all these 4 steps can be summarized through a phase diagram just like this. This here is the empty pycnometer, this here is the pycnometer with the soil, this here is pycnometer filled with water and the soil, and this here is the pycnometer having only the water. Now what we need to know here is this is a phase diagram. So this diagram here is showing that this much volume is occupied by the soil solids and this much volume is occupied by the water content, the water that was earlier in the moist soil sample. And remember that this diagram here does not mean that the soil solids has settled down and the water has come up. No, it does not mean that. It is just a way of representation that this volume is occupied by the water that was in the soil and this volume is occupied by the solids of the soil. And this is the whole volume of the soil that we added in the pycnometer. So now, water content as we know is the weight of the water divided by the weight of the soil solids, which can also be written as WW by WS, where WW is the weight of water and WS is the weight of the solids. Now, as you can see that we don't have either the value of this WW or the WS. What we have here is the weight of the whole soil sample. We don't have the individual weights of the water content or the soil or the solids in the soil. We have the whole weight with us. We don't have the individual weights. But if you look at the diagram carefully, you can see that I can get this W, the weight of water, this water. I can get the weight of this water if I somehow subtract this from this. If I subtract W1 from W2, then the weight of pycnometer is gone, and we are then left with just the weight of the soil. Now, if we subtract the weight of the solids also from this remaining soil, we will be left with just the weight of the water, the WW, which can be written like this. Alright. So now we have the value of W2, we have the value of W1. What we don't have is the value of WS. Now if somehow I got this value, I can calculate the water content of this soil. How? If I got that value of WS, I will get the WW value, and the WS I have already known. So This way I can get the water content value. Now, how to calculate this value? Just for the sake of calculation of this value only, we will proceed with these two steps, the W3 and the W4. These two steps are done just for the sake of finding the value of the WS. Now, if you look carefully, you can see that if I remove this solid here and add same volume of water here, I will get this W4. Alright. So what I need to do is I need to remove this Vs volume of the solid and then replace it with the same volume Vs but with water. So I will remove this, add water to it, then I will get W4. So this can be written in like this. To get W4, what I will do is I will subtract the weight of solids from W3 and I will add an equivalent volume of water. Weight of water having the same volume. What is the same volume? That is Vs. Alright. So, okay, now the thing is how to get this weight of water having the same volume. Now, as you may know that gamma is W by V, or the unit weight is equal to the weight upon the volume. Now, I have the volume Vs that the water needs to occupy. I know the gamma W value. Now, so here from this, I can find the weight that will be replacing these solids. Alright, so this multiplied by this to give me the weight of water. This value right here. So now we will see how to get this weight of water having the same volume. As I mentioned earlier, it will be the volume multiplied by the unit weight of the water. So this is the volume that the water will occupy, the Vs volume, and this is its unit weight. So from here you can see that the weight that we want will be V multiplied by gamma. Right. So which will lead us to this. Now this Vs can be broken down into this Ws by gamma s. Now, okay. So the volume of the solids can be written as the weight of the solids by the unit weight of the solids. Now, this term right here can be written as this. Now, where did this G come from? Now, if you remember, the G value is gamma s by gamma W, and what we have here is the reciprocal of this term, that is 1 by G. So I have replaced this with 1 by G here. Alright. So simplifying it further, this term will go there and we'll take W as common from both these terms. It will be minus 1 plus 1 plus G, and then simplifying it further, taking it down and then rearranging the terms, we will get the Ws value. This is the Ws value that we needed to find out. Now we can easily get the water content value. How? Just look at it. Water content that we know is WW by Ws. WW as we calculated earlier was this. So I will put this value here and the equation becomes this. Simplifying it further, it becomes this. Now all I need to do is fill in the value of this that I calculated in just now, which is this. So this value when put in here will give you the final value of the water content through a picnometer. So what you need to do is just proceed with the experiment, take on all the weights and fill in all these values W1, W2, W3, W4. You should know the value, the G value prior to this experiment, as this is prerequisite, and then you are good to go. You will get the water content value. Now is the method that is the quickest method to find the water content. This is readily used in construction sites, mostly used in the construction of the roadways. As in roadways, we need to find the optimum moisture content for the soil subgrade layer. So we need to determine its water content again and again, and we can't spend so much time in laboratory methods to get the water content value. So what we need is a quick method to get the water content value, and this is a quick method. This will give you the result in just a couple of minutes. Now the key points here is it is the quickest method and it is a quick method. Now the procedure here is take 4 to 6 grams of the sample. Don't take less than this or more than this. This is standard, this is set. Take 4 to 6 grams of the sample and add calcium carbide to it. Now what the calcium carbide will do is it will react with the water in the soil, the water content in the soil, and it will release acetylene gas. Now this acetylene gas will exert pressure on the pressure gauge that is mounted on the apparatus that we are going to use. Now the pressure value that we get is further calibrated with the water content through a chart. So we will just be looking at the chart, and corresponding to the pressure value that we have gotten, we will get the water content value. It is as simple as that. Now this is the apparatus. This here is the soil sample that we have added. This is the calcium carbide. This here is the calcium carbide that we have added, due to which acetylene gas, as you can see here, is trying to escape. It is applying some pressure. This is acetylene gas. This is applying the pressure on the pressure gauge. So this pressure gauge here is showing some reading. Now the chemistry behind this is calcium carbide, when reacts with water, releases the acetylene gas and the calcium hydroxide. Now how we read the water content value is, suppose the dial gauge shows a value of 2 pascals. Just an example. You will look for this 2 pascals value in the chart that you have. Suppose here is the 2 pascals value. Corresponding to this 2 pascal, you will have a water content already given in the chart. Suppose it is 5%. So your job is done here. You have gotten the water content value. So this is how the calcium carbide method is used. It is the quickest method and most readily used in the construction sites.